In this video, we're going to take a look at finding the magnitude and the direction of a vector. So let's begin with an example. Find the magnitude or the length of vector v that has initial point at -1, 2 and terminal point at 4, 5. Now, we saw in a previous video that the position vector v is 5, 3. And that 5, 3 came from taking the initial point, which was x sub 1, y sub 1. I may have written y sub 2 on the previous video, but it is the initial point, so it's x sub 1 and y sub 1. And the terminal point of x sub 2, y sub 2, and subtracting, where we saw that the order is going to matter, and we're going to have the x sub 2 first, and we're going to subtract the x sub 1, and then for the y's we'll do the same thing, but just starting with y sub 2 and subtracting y sub 1. So that's where that comes from. Now, we plotted that point. This would be the -1, 2 as my initial point, and the 4, 5 would be my terminal point. And what we said was that the position vector 5, 3 would come about from plotting a point at the origin and then going to the point 5, 3. And we said that just by looking at this, it looked like those vectors were equal. It looked as though they had the same length and they had the same direction. But we want to do more than just looking at it. You can imagine that as these vectors get larger and larger, that what might appear to be equal could be off just a teeny bit, and they actually aren't equal. So we need a systematic approach to finding the magnitude and the length, or excuse me, the magnitude and the direction of the vector. So the question was posed on the last video: do we have enough information being given this position vector to actually find the magnitude? Well, it turns out that the magnitude of the vector can be found by taking the position vector and using the Pythagorean theorem, right? So what we know is that on our position vector that we have a base of 5 and we have a height of 3. So what we are being given are the legs of a right triangle. So if the magnitude is simply the length of this vector, we're really just talking about what is the length of the hypotenuse. All right, so customary notation to indicate that we're talking about the length of a vector are these sort of absolute value symbols that are around vector v. Now, just a word of caution, or just to give you a heads up, some textbooks will just put the single absolute value symbols. Other textbooks have double absolute values. Now, you're going to see me use the single because that is what is used in the book that we're currently using. But just know that as you go further in math, you may see the double. All right? So here's what I'm going to say. To find the magnitude of vector v, I'm going to say that the magnitude of vector v is equal to, this comes from the Pythagorean theorem, I'm going to take the length of the first leg, which is 5, and I'm going to square that, and I'm going to add that to the length of the other leg, which is 3, and I'm going to square that, and then I'm going to take the square root of it. So 5 squared plus 3 squared is 25 plus 9. 25 plus 9 is, what, 34? So the length of that vector is the square root of 34, and if I really want a better feel for that, I might put that in my calculator to approximate it as 5.83 units. So let's just mark this on the picture here. We have a base of, what do we say, 5, we have a height of 3, and the hypotenuse, which is the length of vector v, is 5.83. I can believe that. All right, second part, find the direction of vector v. The direction of the vector is equal to the angle that's formed with the horizontal positive axis. And we're going to just call that theta. Okay, so the angle that's formed with the positive horizontal axis. So in this picture, that would be the theta that you see down in the bottom left of this picture. So using right triangle properties, we can actually use sine, cosine, or tangent, but what I would advise is that you always use what was given to you. So the 5.83 came from my calculations. I'm going to use the relationship between theta and the values that were given, which are the 3 and the 5. That means that I'm going to use tangent. So I'm going to say that the tangent of angle theta is equal to the side opposite it, which is 3, over the side adjacent to it. And so theta is going to equal tangent inverse of 3/5. I'm going to use a calculator to say that theta is approximately 30.96 degrees, which from the horizontal positive axis is believable. So we now have the ability to not only write the vector as a position vector, but we also have the ability, using that position vector, to find the length or the magnitude of the vector, and then also find the direction of the vector.